Okay, now let's have a look at the effect of processing on the polymers as a material. Now, processing of plastics, we have different types of plastics. Main category thermoplastics and thermosetting plastics. Thermoplastics are softened when heated, and they are recyclable. We can melt them, we can reshape them multiple times. Over a period of time, if you recycle, reuse it over and over and over again, even thermoplastics, the chain cross-linking, they are hydrocarbons, that these hydrocarbon chains will get damaged. They will not have as good properties as the virgin materials. The thermoplastics, they are often injection molded at a temperature which allows the molecule to grow in length, and that process is known as polymerization. Thermoset plastics, the molecules forms a very tightly woven three-dimensional network of bonding. So there is a cross-linking between a chain, one carbon chain and another carbon chain, and with a hydrogen. Because of this cross-linking, they cannot be melted, remelted, and we cannot change the shape. Now, the thermosettings, they are more durable as compared to the thermoplastics. They are stronger as well. Thermosets are stronger than the thermoplastics. That should be thermoplastics here, rather thermosetting. Now, again, as I explained earlier, the polymers, they are made up of long chain molecules. They are made up of long chain molecules during the process of thermoplastic polymers. The chain are aligned in thermoplastics, but these are tangled in a thermosetting plastic. Now, processing of thermopolymers in this way increases both the strength and the modulus of the material, but it reduces the ductility. We can reverse these effects by doing the annealing. As the polymer is heat treated polymers, the chains are allowed to slip more frequently, more easily. They can glide over each other, hence they are easy to mold and remold. If the processing temperature is too high, the annealing will occur. If we increase the processing temperature to very high, that will damage the chain. The reason is because you are breaking the bond and you're forcing the material to become ductile. Because of this way, the material properties are directional. The polymer properties can become directional. They might be stronger in one side but weaker in the other side. And these directional properties are known as anisotropy. So these are the raw materials, different granules. Now, when we process the polymer, different processing techniques, extrusion, and what are the characteristics? Now, in extrusion, the process is usually continuous. They form a uniform solid or hollow or a complex cross-sectional area. Extrusion has a high production rate. They require a low tooling cost, and they have a good tolerance. Then we got injection molding. Injection molding is when we need good dimensional accuracy, complex shapes. We can create a thin wall, very high production rates. The dies, they are expensive. Then we got the structural fold molding. Large parts with high stiffness to weight ratios are molded by that structural foam molding process. Less expensive tooling is required as compared to injection molding. The production rate is slow. Blow molding, we want for hollow, thin wall parts, for example, the bottles, high production rate and low tooling cost. Then we got rotational molding, large hollow items, of simple shapes, low tooling requirements, and low production costs. So here they are adding the color in a polymer process. Catalyst. Sometimes they add like calcium carbonate, CaCO3. Health and safety. So it's cleaning it, just putting a little bit oil on it. Then we have a thermoforming process. It's a shallow or low deep cavities. We perform the thermoforming process. It does not have any high tooling cost. Production rate is medium. Now, and then we have the casting. It's simple. Shapes can be formed. Intricate shapes, sometimes we are able to make that one. Casting is laborious process, so hence low production rates. Now then we have composite materials. Composite materials has an issue that it's an expensive process, and the tooling cost actually depends on the process. The high cost is the labor cost in composite. Now let's go to next one. Okay, this is the injection molding machine. So you got a mold clamp, injector pins, the moving die which moves forward and backward, then there's a stationary die. And then there's a hopper. In the hopper, you put the material in the hopper and the motor actually turns the blades which are inside. And as the material moves from hopper all the way to the stationary die, what actually happens is the material gets heated and mixed properly. When it's there, the moving die and the mold clamps, they come together, the stationary and moving die come together, and the fluid goes into the molten material, goes into the die. Then the die absorbs all the heat and you just release the moving part, moving die separates, and you can take out the mold from inside. So this is the injection molding process. That's the hopper. We just put the material in. Now there are some thermocouples, the heaters and thermocouples, which actually make sure the material is at certain temperature. And then from here, the molten thermoplastics actually moves forward into the die, into the mold, and that's how we actually injection mold the material. Now, the pitch, which is a difference between that point and that point, the diameter of the barrel, and the distance between the barrel and the inner dia dictates the material flow rate. Okay, so different steps in injection molding. Okay, so first, if we got this one is a rotating screw. Step one is build up material in front of the screw brushing. Pressure pushes the screw backward when the sufficient polymer has built up. When the sufficient polymer build up, it just moves that one back. When the mold is ready, the screw is pushed forward by a hydraulic cylinder, filling the sprue and mold cavity with this blue polymer. And then the screw begins rotating again to build up more polymer. And the third one, after polymer is solidified, cured, the mold opens and eject pin removes the mold. And then the other material is already ready into the cavity space between the mold and the screw. Now, molding tool. Now, if you have a look at the molding, the mold material, you can actually see these things like the sprues. These are where the material enters, and then there are some runners or branch runners, and then there are some gates which lets enter the material. If the material entered too quickly, too slowly, there will be some cavities. I will bring a sample next time to show you injection molded, which we molded three days ago. So it's to do with a beacon for the shark. But I will show you that material. Okay, now next one. Sometimes the material does not went all the way in. We call it short. The material does not went all the way in. Sometimes we got an excess material. This is known as flashing. Flashing can be removed, but again, it takes extra labor, and loss of material and so on. So it's not a good idea. So that on the top, you can see the flashing here and there. So flashing and flashing. Then sometimes we got the gas burns, which is if it goes, the temperature increases a lot, so we get gas burns. Sometimes we got distortion, so you can have a look at same specimen, same product, but they are distorted. When one side is cooling faster as compared to the other side, to do with the dye material and everything. Now, if you if you increase the heating process, that can increase the degree of polymerization. Now, the way the polymer moves into mix with the screw and everything, it results into a polymerization chain to be made. Now, we can add some filler material to provide extra strength, for example, glass, carbon fibers, to change the mechanical properties, to get better mechanical properties.